Hello, Chemistry 10HH students. I know I told you that video number 49 was the last video of the year, but I just found out that I'm not going to have you today, so I'm just going to record myself working through what we would have done in class. So this document, if I haven't already done so, is going to be posted on Google Classroom, both the blank document and the answers, which I will be typing on right now. All right, so let's start by looking at number 1. I'm going to use abbreviations here. I'm okay with using abbreviations for the quiz. For number 1, this is just LDFs. Since we know the diamond is only carbon, therefore we can't have anything more than that. You don't have to write LDF for B. Ionic bonding is completely sufficient, but it is not wrong to also put it. And then it's debatable whether or not you'd put dipole-dipole. I would err on the side of no. For C, London dispersion forces and dipole-dipole. For D, we're actually going to want to draw this out before making our decision here, to make sure that the oxygen and the hydrogen, see if they're connected or not. And then since the hydrogen and the oxygen are not connected, while it has dipole-dipole forces, it does not have hydrogen bonding. And then CH3OH, again, we'll have to write this one out. Since the hydrogen is directly connected to that oxygen, it is a hydrogen bonding force. You could put dipole-dipole, you could not. Either way is really fine here, but you do have to put LDF, you do have to put hydrogen bonding. All right, let's take a look at number 2. So we're given the boiling points, and we just need to justify it. So I see that CCl4 has the higher boiling point. Right, so both of these only have LDFs because even though there are polar bonds, they're symmetrically placed around the carbon. You could sketch that out, but they're both tetrahedral. That's how I realized that. And since everything around the carbon was the same thing, I knew it was symmetrical. So then I just have to think to myself, since they both have LDFs, why does CCl4 have more LDFs? Since you guys are not yet in AP, I probably wouldn't require on the grading rubric that you use the phrase more polarizable electron cloud, but it's a good thing to include. Okay. Okay, so both of these have both London dispersion and hydrogen bonding. There's actually 2 ways you could approach this. No, I'm incorrect. There's only one way that you could approach it because their molar masses are really, really similar. So this has to do with the fact that H2O can just hydrogen bond more than HF. Molar mass really isn't a factor here. HF actually has the higher molar mass, but they're very, very similar in any case. So francium, that is on the metal side of the periodic table. There's only going to be one answer for each of these two, for anything like number 3. This will be atomic. Silicon and carbon are the only 2 I expect for you to be familiar with. This is very likely to be a covalent network solid. And then this is ionic. Okay, I'm going to put this on the next page so we don't run out of room. So this is the same data table that we had in class on Friday. I just copied and pasted it, but we just have different mass of ice and we have different initial temperatures. So I'm going to break it down into the steps. So I'm going to heat it from -30 to 0. Step number 2 is going to be the heat of fusion. And step number 3 is going to be to heat from 0 to 45 degrees. And then we just add them together. So I'm going to use Q is equal to MCP delta T, both for step 1 and for step 3. And then I'm going to go ahead and convert this to kilojoules just because. And it was just because of sig figs that I did 15,000. In my calculator, I got 15,225. And take a look at the heat of fusion units. They are in kilojoules per mole. So I'm going to need to use the molar mass of water. And then I just use the heat of fusion. And then I round that to 3 significant figures. And then I just have another Q is equal to MCP delta T. This time I need to use the specific heat capacity of liquid water. I round that to 2 significant figures, so I get 47,000 joules, which is just 47 kilojoules. And then all I have to do is add my 3 answers together. I round it to sig fig, so I get 146 kilojoules. For your actual quiz, I probably would stick to just 2 steps at a maximum, not 3. And then there's also going to be a true-false. That being said, questions like number 1, number 3, and number 4 will be shorter than the ones that I've selected for the quiz review. I just picked these because I thought they were just good practice problems that hit a wide variety of topics. Great, thank you for watching. I hope that this helps a little bit. I just found out, when you guys did that we weren't having class today. Would have really obviously preferred to have done this in person. But since I know this will make you laugh, smash that like button or don't. It really doesn't matter to me. Anyway.